Good morning, everybody. We're going to go ahead and get started here. Welcome to our webinar, SQL Server 2016 Data Compression. My name is Greg Samuels. I'm the CEO of Solvaria. I also have on the phone with me Pete Miller. Pete Miller is one of our senior SQL Server DBAs. The original speaker, Ra Osalaj, is sick today. His voice has gone out, but we do have him on the moderator panel. So we'll be able to answer questions, and I'll be throwing it to Pete every now and then for some clarification points. So let's talk about the agenda. So the agenda is we're going to discuss the following on this webinar. I'm going to tell you a little bit about Solvaria. We're going to talk about the benefits of data compression. We'll briefly describe what it is. We'll describe what it isn't, common compression scenarios, things you should consider before getting started with your compression implementation, and lastly, we'll discuss the implementation roadmap for this feature. Please bear in mind this webinar is geared towards having a conversation about data compression. We will not be demonstrating compression scenarios. If you have interest in moving forward with implementing data compression, we'd be happy to help you there. So let's get started. How to ask questions. So in the Skype Q&A platform, you'll see at the bottom there's a Q&A panel. You type your name in the first box of Skype Q&A, and then you type your question in the second box, and then you hit Ask. We will answer questions during the discussion portion of the webinar. Please note the webinar is being recorded and will be available following the presentation. So a little bit about us. Solvaria is a boutique IT consulting firm. We were founded in 1997 in Richmond, Virginia. We serve local, regional, national, and international clients. Our team is comprised of exclusively senior-level talent who served as CIOs, program managers, team leaders, and database administrators in organizations ranging from growth-oriented small businesses all the way up to Fortune 500 companies. We're divided into two sides of the house. One side is strategic leadership, which is where our CIOs and our program managers live. The other side, which we'll talk about today, is our database services side, and that's where our 11 full-time DBAs reside. Our depth of experience coming from our senior talent really allows us to approach every company's situation and with familiarity. And we are proud to be recognized as a Microsoft Gold Partner in Data Platform. So we support DBAs by providing a full suite of services. We do everything from 24/7 monitoring, maintenance, and troubleshooting, all the way to statement of work projects. We can look at performance tuning, patches, etc. You can note from the slide that we have a range of services we can offer to your company. In addition to the Microsoft stack, we also have DBAs who support Oracle, all the way 8i to 12c. We can support other database platforms such as PostgreSQL and MySQL. Okay, so let's get right into it. So let's talk about SQL Server 2016 in general. Many IT professionals still follow the wait until the first service pack theology before upgrading to a product's next major release. Well, the delay period for upgrading to SQL Server 2016 is over. Last November, Microsoft released Service Pack 1, and they included a few extra carrots. A number of previously Enterprise Edition only features are now available for you to use in all editions of SQL Server 2016 Service Pack 1. This table above shows features that were previously available only in Enterprise Edition. As you can see on the right, most of the features have been enabled in all editions for SQL Server 2016 SP1. So for those who are asking, what benefit is there for me to upgrade? We say a whole lot. If you're like me, you always wanted to use these features, but rarely had the opportunity due to the Enterprise Edition price tag. Now that you have access to them without having to pay an arm and a leg for it, you still have to go through the upgrade, but we'll talk about that in the future. Pete, just a clarifying question for you. What are we seeing in the marketplace around customers and their adoption of SQL Server 2016?
Well, with 2016, the biggest hurdle that a lot of companies that they have is the price tag that's associated with it since Microsoft changed their pricing model. A lot of people are kind of hanging out on 2008 R2 as long as they possibly can, but I think with the end of life of 2008 R2, we're going to see a lot more SQL Server 2016 upgrades.
Okay, cool. Today we'll discuss data compression. It's one of those features that's more easily adopted. SQL Server's data compression feature has been around since version 2008. It used to only be available in Enterprise Edition, I've said before. So even though Service Pack 1 made it generally available, today's material applies to any Enterprise Edition version since 2008 was released. So the obvious benefit of data compression is that it saves disk space. While disk drives and SSDs are forever getting cheaper and cheaper, our appetite for cramming more and more useful information into our databases is probably on pace with the declining cost of storage. So we're still having to balance the amount of data we store versus how much storage we can afford. If your databases are on-prem, compression can mean less requests to the storage or VMware admins for additional space. Just keep in mind, however, that you won't necessarily see any reduced space consumption with your backups. We are using SQL Server's native backup compression or some other tools' backup compression, aren't we? If your backups are already being compressed, then you won't see any space savings there. Nowadays, we're seeing clients move towards hosting mission-critical databases on SSD drives. If you're in that camp, you'll definitely be able to pack more data onto those SSDs. It's incredible to see how much of a difference the SSDs make. Loading data into the buffer pool is super quick. As your data volume grows, you won't have to worry about going back to the checkbook to get more SSDs. As we look to the cloud, storage costs become even more important. We're not just dealing with a fixed cost that was most likely expensed as part of a capital budget there. Usually we're dealing with a pay-as-you-go expense. So when considering implementing SQL Server in the cloud, we should definitely implement data compression in order to limit our month-to-month costs. This is true whether you're implementing SQL Server in Azure, Amazon, AWS, or with some other cloud provider. Data compression can potentially improve the performance of your workloads. It's due to the fact that we can stuff more data pages into SQL Server's memory space, also known as the buffer pool. The data is stored in memory, compressed the same way that it's stored on disk. With more pages packed into the memory, there's less trips back to the disk. Disk I/O is usually the slowest operation in the sequence of events required to service a query. Less trips to the disk means less waiting time for your queries to complete. Pete, tell us a little bit more for the uninitiated DBA or the more novice DBA. Tell us a little bit more about the buffer pool and why that's important.
Well, the buffer pool, the primary purpose of the buffer pool is to reduce the database file I/O operations and to improve the response time for your data retrieval. In SQL Server 2014, I know we're talking about 16, but in 14, administrators were given the ability to extend that buffer pool to non-volatile storage, such as your SSD drives. So basically, it allows all of your data, as much data as possible, to be stored, so you're not having to go back to disk to retrieve that information, which improves your query times.
Okay. Let's also keep in mind that non-enterprise editions of SQL Server also have memory caps. For instance, so packing compressed pages into the buffer pool can help us maximize what SQL can do with its allocatable memory. Data compression does come with a cost. It requires CPU time to compress and decompress data. That's both for writes and reads. Of course, we burn CPU compressing data on writes. SQL Server also has to consume CPU to decompress data that it's used for joins, filters, sorts, or column output. Due to this, frequently asked data may cost more in CPU cycles to decompress over and over than the amount of storage you're saving. Users can care less if you're saving 500 gigabytes of space if their queries are running slow. So SQL Server provides two levels of data compression, row compression and page compression. Row compression helps store data more efficiently by storing fixed-length data types in variable-length storage format. Essentially, SQL Server uses the least amount of bytes to store specific values. All numeric data types like int, float, decimal, and money are converted into variable-length data types. Char and nchar data types are stored as variable-length data types. Null and zero values are optimized and no space is consumed. The metadata of records reduced. Page compression is a superset of row compression. In addition to storing data efficiently inside a row, page compression optimizes storage of multiple rows in a page by minimizing the data redundancy. Page compression uses prefix compression and dictionary compression. Prefix compression looks for common patterns in the beginning of the column values on a given column across all rows on each page. Dictionary compression looks for exact value matches across all columns and rows on each page. Both dictionary and prefix are type agnostic and see every column value as a bag of bytes. We have some website links for you guys, which we will put on the website and will be available after this presentation. We can perform row and page level compression on heaps, clustered indexes, non-clustered indexes, partitions, and index views. Pete, I just wanted to stop here for a second. I've heard a lot from the DBAs talking about heaps. Do you want to talk a little bit about heaps and why we're not real big fans?
Sure. Basically, heaps are like this collection of data to where it's just thrown in a pile. Proper use of indexing will allow us to better retrieve that data. For when the heap is, if you're looking for it, you're going to have to read the book from one end to the other just to find the data that you're looking for, which causes a lot of extra I/O operations.
We can mix and match how we apply compression to tables, indexes, and partitions. It doesn't have to be one method applied across the board. Even within a table, we can compress one index with page compression, compress another index using row compression, and leave the rest of the indexes uncompressed. The point here is that we should use the compression scenario that is most beneficial for each index, heap, or partition. I'm guessing you already have a database for which you're considering compression. Microsoft has published some very useful queries that will help you determine ideal compression options for your existing databases. We'll skip the demo today in order to make sure we have time to discuss the roadmap to implementation. Log tables, audit tables, and data warehouse fact tables are almost certainly your first targets for implementing data compression. These all are usually write once and read lots, often with high frequency of index or table scans. Frequent scans can really benefit from data compression if you have enough space in the buffer pool to load the frequently accessed data and you have the horsepower to support their decompression on access. Now we have an idea of what data compression is and how it can benefit us. We think it's important to talk about what it isn't. We'll probably get back a ton of disk space once we compress our objects. We have to be careful not to fall victim of the mentality of now we can store all of this information in the database too. Trust me, that monster comes with its own demons. It's always best to only store what you need. Along those same lines, let's make sure we're remembering to prune data once it's no longer useful. For example, you now have 20 to 70% more space to store log records. Don't do it. I guarantee you'll use those even older or more frequent log records just as little as you did before you turned on database compression. We also want to point out that data compression is not a one-way street. You can turn it off just as easily as you turn it on. So when you find that compression actually adversely impacts performance of an application, you can execute another alter index or alter table. If you do experience adverse performance impacts, please don't go writing off compression completely. If this happens at all, it's more likely to be specific to a certain table, index, or partition. Let's use some scientific methodologies for eliminating the issue, because more likely you'll want to leave some data compressed. If we're following application infrastructure lifecycle best practices, we're implementing compression in our non-production environments first. So hopefully if we experience a performance issue there, we'll have time to experiment with different compression scenarios for the affected objects or just decompress the objects and never do it in prod. You may have to convince the non-production environment devs and users to give you time to work through the issue. This is your chance to hone your approach to handling the situation in case it happens in prod. Decompression is simple. Just make sure you have the space needed to perform the decompression, plus the space required for the resulting decompressed table. Also check the fragmentation after the decompression operation is complete. Most likely you'll need to reorg or rebuild afterwards. Before we go into implementing data compression, there's some practices that we want to make sure we're already doing. If we aren't, we'll likely need to adopt them before tackling compression. This is actually an area that our customers pull on us very frequently to do, which talks about tuning. Pete, you want to talk a little bit about database tuning and why that's important to an environment?
Sure. So the database tuning is makes sure that your queries are responding as quickly as possible. One of the easiest and quickest ways to tune your database is to add RAM. The more memory you have, the more you have to work with. The next easiest step would be your index management, which is going through your indexes and making sure that you have proper indexes on your objects based on your individual usage. And with the creating of the indexes, because your data does change, you're going to need to rebuild or reorg those indexes on a frequent basis. And then most important, updating the statistics on those tables, because the statistics are what gives the SQL Server's query engine the best path to your data. Now, the hardest part and the most trouble one is the actual query tuning, going in and updating your queries. And that's hard because, especially if you're using a third-party product, sometimes you don't have the luxury of being able to change the way that the data is being retrieved. So that's.
So some things about data compression. One thing about this tuning is when you talk about tuning, you also talk about defragging the indexes, and Pete's talked a little bit about fragmented indexes. We talk about using different maintenance solutions. One of them is the Ola Hallegren maintenance solution. Pete, that's not specific to us. That's pretty much an industry standard maintenance plan, correct?
Yeah, it's a very, very popular tool that's free to users, and I've seen it used from all industries in all versions of SQL Server.
Okay, cool. So part of this, the index defrags, you want to make sure that it accommodates row and page compression options. So once you pull the trigger on compression, you don't want your maintenance scripts turning it right back off. There are situations where some rows and pages might not get compressed. That typically happens when data is inserted in bulk without tab lock hint. So you want to make sure your maintenance solution catches those situations and compresses those rows or pages. Make sure your index maintenance solution accommodates compression, as I stated before. The last thing you want is to end backup with an uncompressed object because your script undid all of your hard work. In the end, yes, you'll get back space after compressing your data. However, SQL Server will potentially require extra space during the initial compression of the object. If you are already running some sort of index maintenance scripts, you might already have it covered. Just keep in mind that SQL Server will keep the uncompressed objects around until it's finished creating a compressed copy. Afterwards, the old object space will be released. You will still need to manually reclaim that space on the disk, however, by initiating a DBCC shrink file. We recommend waiting on reclaiming the disk space, though. You should give yourself time to figure out whether you'll need to decompress any objects once they get out there in the wild. Also, before you get too far down the path, make sure you have adequate performance monitoring in place so that you'll know if compression burns up the CPU. Please use your monitoring tool of choice. Pete, I'm going to throw another question to you about monitoring tools. We see customers that always ask us to make tool recommendations, and we usually say that we don't recommend one specific tool because we've seen them in use all over the place. But I'm going to put you on the spot here a little bit. What are some of the more common tools that you're seeing out in the marketplace?
So for monitoring, for smaller companies, Redgate has a SQL Monitor product that's pretty inexpensive and pretty popular. The bigger guys I generally use Idera's Diagnostic Manager or Spotlight for Spotlight, which I can't remember who does that one. But there's a whole bunch of them out there, and it's kind of like you want to make sure that the monitoring tool that you use kind of fits your comfort level and kind of fits your company. So they're all really good, but you want to make sure that you do your due diligence and pick the one that's right for you.
Cool, thanks. So you've gotten this far. You're comfortable enough with your indexing strategy. You're certain that your indexes are being defragged and the maintenance routine you're using accommodates compression. You're sure that you have enough space in your MDF, NDF, LDF, and TempDB files to create the compressed data structure on the initial rebuild. And now you're ready to start pulling the trigger. So let's do it. You're now ready to begin compressing objects. Microsoft has some cool queries you can utilize for identifying good compression candidates, as I stated before. We recommend at first only compressing a couple of objects. You'll want to dip your toe before you do a full cannonball. Start with compressing those objects in the development environment and propagating the changes outwards to production. Remember, you can decompress an object if you get into trouble. Doing just a few objects at a time will prevent you from having to do a full database restore due to being overzealous. I think you and your IT managers would prefer to build confidence in compression slowly versus having to roll it back after a big push. Just like with index maintenance, it's best to perform your initial compression during a maintenance window. Who wants table locks in the middle of the day? Depending on your disk subsystem and CPU capacity, compressing gigabytes of data could take a very long time. If you're on Enterprise Edition, consider using online rebuilds. Be sure to look for uncompressed pages. There are certain situations where SQL Server skips compression of new records or recompression of existing records. As long as your maintenance solution accommodates compression scenarios, you should be fine, but it's best to check anyway. So today we've talked about the benefits of data compression. We've talked about what data compression is. We've talked about what it isn't. We've talked about some common compression scenarios, things you should consider before getting started with your compression implementation. And lastly, we discussed tips on the implementation roadmap for the feature. At the end of the deck, you'll find some contact information in case you'd like to have further discussions with us regarding data compression or any other features of SQL Server. So at this time, we're going to go to our Q&A panel, and we're going to see about what questions we have. So we do have a question about compression, which is what tables or what databases or tables make good candidates for compression. Pete, do you have any thoughts about this? I know we mentioned some of the more common ones.
Yes, for me, I think it's more like log files, files that you basically write once to and do a lot of reads from. Because of the nature of compression having to the CPU of kind of pushing it all back together. I think if you have like a transactional table, I think that would be less of a candidate than something that you're just reading from.
Okay. We did have another question which was talking about implementing compression in dev and test environments. The question was, what are companies doing in terms of dev and test environments to start to experiment with this? I'm gonna start answering this question, and then I'm gonna throw it to Pete for any additional thoughts. But we're seeing a lot of companies use Azure as a way to spin up a dev and test environment, to be able to very simply provision a server, copy the data over to the environment, and then really start to fool around with it. So implementing Azure infrastructure as a service and building SQL Server much as you have it on-prem, and then start to apply something like data compression in that environment to see how it would operate in your environment. And then that's the point where you can turn back into your prod environment and start to make changes. Pete, are you seeing the same activity going on, or do you see a lot of customers with still sticking with on-prem implementations of their dev and test environments?
I think being with the nature of the dev and test environments, in their own hardware, I think the trend is to move to a hosted solution, whether it's Azure or AWS or whatever, to where that when they're not using it, they can turn it off, so they don't have that constant cost that's associated with physical hardware.
Okay. I don't see any more questions in the Q&A panel. We're going to keep the Q&A panel open for probably another 5 or 10 minutes. And if somebody has any additional questions, feel free to submit. Also, here are our contact information. We've got Pete and Ra and myself. You've got our email addresses. Obviously, our address is solvaria.com. We're found on Twitter. We are Solvaria. I wanted to thank everybody for their time today, and we are available for Q&A, and we'll be available at these email addresses at a later date if you have further questions or want to start to explore compression. Okay? Thanks a lot. Have a great day.